All right, welcome again to Amobi Publishers, and this is number 23. As you can see, the question is two variables, A and B, are connected by the equation A equals KB power n, where K and N are constants. And then we have the table below giving values of A and values of B. And because we have an exponential equation, we need to convert this exponential equation into what we see here, a logarithmic linear equation. In other words, we convert the exponential equation or the power equation into logarithmic equation, so that now we have the logarithm of A. If we look at this equation here, we have the logarithm of A. In other words, we functionalize the whole equation so that we have logarithms. So we shall have the logarithm of A equals to that n multiplied by the logarithm of B plus the logarithm of K. Remember, if numbers multiply, the logarithms will be adding, and if we have a number to its power, then the logarithm will multiply by that power, right? So that is something to remember. So this is the linear equation. So in the first requirement, we are told to find a linear equation connecting A and B, and this is the linear equation connecting A and B. Once again, a logarithm of A is equal to n logarithm of B plus logarithm of K. Then now down here on the square paper provided, draw a suitable straight line graph to represent the relation in what we have A above here, and we are given the scale to use. Fortunately, we have been given the scale to use. Sometimes you are not given the scale to use, but here we have the scale to use. And therefore, I am translating this scale, that is 1 centimeter, to represent 0.1 units. I'm translating it to the smallest box. If we can count together the smallest box here, we have 5 small boxes in this centimeter. So one small little box will be 0.1 divided by 5, and that gives us 0.02 centimeters. So on our y-axis, we have the logarithm of A, and the scale is 0.1, as you can see, right? And on our x, we have log B, and the scale is the same, that is 0.1 for every centimeter. So what we are supposed to do is to convert our table here, as you can see, to a logarithmic table. And I have my logarithmic table here. You can take your logarithm table and confirm that the logarithm of 1.5 is 0.1761, and so on. The logarithm of 1.95 as 0.2900. So confirm these values. So we have A here, and we have the logarithm of A across here up to the end. So 0.6532 is actually the logarithm of 4.5. In the same way, you get the logarithm of B, so that the logarithm of 1.59 is logarithm value or logarithmic value 0.2014, and so on. So that now the logarithm of 11.5 is 1.0607. Okay, so the plotting is not a big deal as such, and when you plot those values, ensure that you go on the conventions of plotting. So you have that kind of a line, which is very nice, and see to it that you see, we can see the intercept here. Right, the intercept here is almost, if we say these are 4 boxes, 1 2 3 4, and each box, remember, is 0.02, meaning this intercept here is 0.08. It will be very important for us as we move on to the next stage. It will be very important for us, so remember that as we move to the next page. So far so good about the graph. So far so good about the graph. So we'll continue with the question. So here we have been told that to use our graphs to estimate the values of k and n in to 1 decimal place. So use the equation and the graph. The equation, remember, it was like this: logarithm of a is equals to n logarithm of b plus logarithm of k. If we superimpose that logarithmic equation into the form y is equals to mx plus c, you see that m, which is the gradient of that line, is related to n, and x is the x variable, that is logarithm of b, while y is logarithm of a, that is the y variable, and the y-intercept c, that is the constant, is the logarithm of k. Remember, I insisted on the value of the y-intercept. Okay, and then so we are saying that the logarithm of k is the y-intercept of the graph, which I have shown, and it is 0.08, meaning that k is the anti-logarithm of 0.08, and you can go to your logarithm table and see that that value is 1.2023. Okay, if you round off this number, or actually I got this anti-logarithm from the calculator, so you can also use your calculator. So if we round it off to 1 decimal place, we are saying k is equals to 1.2. N, remember we said, is the slope, and the slope is change in y over change in x, which is now the change in the logarithm of a over the change in the logarithm of b. I will show you in a moment how I got these values, if you can remember my graph. Look at this graph again, the way I have drawn it. Okay, so pick any point along this line, any convenient point. Like for example, you have seen my convenient point is here, and if one box is 0.02, so that translates to 0.04. Okay, so this value here is 0.24. Okay, and then up here we have 0.6 to 0.62, because that is one box, so change in y becomes 0.62 minus 0.024, while look at the y, I mean x, look at the x, come down here, this is 0.98, because one little box is 0.02, and here we have 0.28. Okay, so the change in x will be 0.98 minus 0.28, and this is what we have here. Use your calculator and evaluate, so that our n to 1 decimal place is 0.5. So thank you very much for being together. If you like the video, kindly like it and subscribe, so that every other time we have a video like this, you will get updates. Bye bye.
Kidogo kidogo ni kinyataja.